Hello and welcome back to part 3 of HSMWorks tutorials. In this episode, part 3, we're going to be dealing with tube jig. Along with sheet metal on our CNC, we created a tube jig, which I will pull up some pictures of, and the tube jig allows us to use the CNC. It puts vices on the CNC and allows us to use the CNC to cut tube as well as sheet metal. So typically it's very difficult to actually mount any sort of tube onto, like, say, the MDF board. So we were inspired by how Team 1678 did theirs, and we created a tubing jig, as you can see here. So this was a test piece run with the tubing jig. So we have a couple vices set up along here that are, we use a test indicator to indicate them to the axes on the CNC, and we're able to cut tube just like this. And so to 0, so typically with the sheet metal you just pick an arbitrary 0, it doesn't have to be exact or anything, but with tube device, since the tube is held in place securely, you need to have a secure 0, a fixed 0. So what we use, I don't think I have a picture of it in here, but we have a electronic edge finder. So you can either have a mechanical edge finder, which is a little knob thingy, or you can use one of these. So electrical edge finder, so that just makes it a lot quicker, since as soon as it touches the metal, it'll light up, and that's how you know you're indicated to that, and then the CNC operator will set like an offset depending on the diameter of it. So this episode, this part, we'll be talking about how to generate the toolpaths for that. So the part we'll be using is part of our 2018 robot once again. And it is a drive tube. So this drive tube sort of covers a lot of the different functions you'll be using with a milling tube. So as you can see, this one I've already got. So for I'm going to suppress pocketing in here. I was not actually on it. I was just messing around with the weights. So as you can see, with this one, I've already had a ton of toolpaths, so I'm actually going to just delete all of these. Okay. So as you can see, I start. So when we 0 to the vise, we'll have to flip this a couple of times because there's different features on all the different sides, and so you have to make coordinate systems for each side. So it's pretty self-explanatory. Previous one, you saw a coordinate system. Click on the corner, set the y-axis to the long one, x-axis to the short one, and yeah. Then you create a job. So you need a separate job. Because each side has its own coordinate system, which means you'll need a job for each side. So for that, I'm going to start with this side first. So model, select the model. Okay, so now I have a job for this one. So one thing you're going to want to do to help out with the machining process and the machinist, CNC operator, is to label each side by number. So I will call this side number 1, and then on the physical part you'll use, you're going to want to label that side as, say, number 1, 2, 3, or 4. So we'll start off with the center drill. So all these holes on here, you'll need to use a center drill to mark them. So we'll use the 3/16 center drill. It's the 3/16 actually. 3/16 center drill. There you go. And then once again, all you do is select all holes. Just select the surface, not the edge. Okay, those holes. See these holes as well, and these. So that's all the holes on this side. Now, here's the thing with this. HSMWorks will actually automatically select the holes that are in the same plane. So you can see it's actually trying to use the center drill to drill all the way through the tube. We don't want that, first of all, because center drill isn't long enough, and also because that would mean our center drill would be actually doing the actual drilling. So we'll need to set our heights. Most of the heights you can read about them on your own. They're not very interesting. Retract height, clearance height. It's the height it goes to in between each move, and the retract height is how far it goes up before the next one. So it's the key one really you're going to need is bottom. So we're going to want to go 50 thou as usual down for the center drill. So I'll go negative 50 thou. You see, instead of going all the way through now, it just goes up to that surface. And then next, we're going to want to use the 3/16 drill bit. So because flipping the tube each time, you're not going to get the exact same, 0. You're going to want to use your drill bit to on the holes. On certain holes, you're going to want to drill all the way through. So like the holes that are through all, like these ones right here, you're going to go all the way through with these. And it also saves a lot of time. So all the holes that are at least 3/16 in diameter, I believe these are all number 10 holes, so they all qualify. And then head over to here, and then drill tip through bottom, breakthrough depth 0.1. And just to verify that all these holes are through holes. If it's larger on the other side, like some of these ones, doesn't matter, because you're going to be enlarging the hole later on when you get to that side. And drill bit, you're going to choose 3/16 drill bit. Check mark. So I'll call this one 1 side 1 center drill. Call this side 1 2 3/16 drill. And then we're going to want to cut out each of these bearing holes. So we'll be using the 3/16 end mill as usual. The 30 IPM. Actually, for the tube, it's typically not. It gets a little weird with the tube because it's sometimes not as rigid, and so I like to run it a bit slower at about 25 IPM. And the model, I'm going to select proper holes. 2D contour once again. So what's nice about the tube is that these parts, these cutouts, they don't actually fly out of the tube. They just sink right down inside the tube, just like that. And then height. So this is 1/8 inch thick tubing, so you can just go all the way through in one pass. But we're going to want to ensure that we cut all the way through. So we're going to want to lower it by 30 thou once again, just like that. Multiple depths, since, as I said before, this is 1/8 inch, we can go all the way through, and for tubing, just as always, you're going to want to ramp it. You can have the lead out because you're cutting on the inside. Ramping, start height, 20 thou up. As you see here, ramps down in a spiral and cuts it out. So we're naming this one side 1 3/16 end mill. Operation number 3 3/16 end mill. Okay, so this side is fully done. So now we can move on to the next side. This side right here. Or actually, since if you look on this side, there's not very many. There's only these 8 holes right here and nothing else. We're actually going to take a look from the other side, the reverse side, and you see there's more holes here. So you're actually going to want to make all of your holes on this side and drill all the way through, but you're going to want to skip these. And this side is only drilling as well. So we use this coordinate system, this one right here, this one, to create a new job. since it is a separate coordinate system, different 0. And then so now we can just drill. So once again, we're going to want to mark them with center drill. And just select same diameter and verify it picks all of them. And then we're going to want to set the bottom height again. So from the we do model top just like this, and then 50 thou into it, just like that. So it cuts 50 thou. Mark. Name this side 2, 1 center drill. So I'm gonna name this side 2. I'll call this 2. This job 2, and then we're gonna want a 3/16 drill. So because some of these don't go all the way through, we're going to want to make this 2 separate operations, but then like in the last video, we can post them all as one since it's the same tool. 3/16 drill bit, we're going to select only the holes that go all the way through for this one. So you have to manually select these. So it's just these 8 holes that go that are on this side and this side. So then we'll want to go all the way through. So it's actually didn't recognize those, but then we can just do from selection. So that's the bottom right there, and then we're gonna drill tip through bottom and go 0.1 inches, just like that. And you got to remember that the CNC operator has to know that you're drilling all the way through and use parallels. Otherwise, they'll drill into the vise, which is not good. There you go, all the way through. Then I'll call this side 2, 2 3/16 drill. And then we're going to want to do all the holes that don't go all the way through, so the rest of the holes. Drill tool. And then, once again, you need to manually select these because they are, if you do select all, it'll select the other ones as well. So those holes, and then set the height. So from hole bottom, it's the correct one. Since there's no hole on the other side, I won't detect those and go all the way through. And then we just do drill tip through bottom, 0.1 inches, all the way through one side. I mean, and that's done, just like that. Side 2, 3 3/16 drill. And then, so we've already done this side 1, so everything, all the features on here. Side 2, we've covered these features here, as well as these features on this side. And with the side 1, on this side, we've also covered all of the, at least 3/16 large holes. Well, the 3/16 holes. Which will actually see, these are 0.201, which is for a number 10, it's a clearance fit for a number 10 bolt. Those will be drilled out with a drill press later on, but those holes can stay like that. And then so the only operations we need to do on this side are to make these larger than 3/16 holes, well, much larger than 3/16 holes. So the bearing holes and these holes. So these holes on the actual model, there's the bolts that mount the gearbox. The heads need to fit through here since they sit flat on there. So we can start. So we'll call this. This is side 1. We call that side 1. We call this side 2. So we'll call this side 3, and use the coordinate system. This one right here. Coordinate system. Make sure that you can see they all point in a circle, essentially, the z-axis, just to make sure that you don't actually accidentally put 2 zeros on the same corner. Otherwise, that won't work because the vise only holds the tube a certain way. So select the coordinate system in job. The model's already selected since we're in the part menu. So yeah, we're in the part menu instead of in the actual part instead of assembly, because it's just with the tube cutting jig, it's just one thing, one part at a time. So I'll call this 3. Oh, I actually selected the wrong coordinate system. This coordinate system, this one. Yeah, make sure you always have the correct coordinate system. So we can skip the drilling since that's already been done and go straight to 2D contour. So we'll be using, once again, 316 flat end mill. And since it's tube, we'll be running a bit slower, 25 RPM. Model, select all the edges, contours that we'll be using, cutting out. So these. Make sure to reverse if it's on the outside. And if you select the surface, by the way, it'll detect it as two, which detected as two contours, which you don't want to do. So ideally, you'd want an end mill that is long enough to go all the way through, but we don't have the properly sized ones. And also, I personally don't like going all the way through with the end mills because it messes with your part rigidity, your end mill rigidity, I mean, because you need to use a fairly lengthy end mill. Especially with these ones, since this is a 1.5 by 2 inch tube, you have to go through, your end mill will have to be at least about like 1 3/4 inches long. So I've selected all the things we're going to use 2D contour on. For the heights, we'll be going from the contour, we'll be cutting an extra 30 thou, so that we make sure we cut all the way through. And then no multiple depths because it's 1/8 inch. We can go all the way through in one pass, and then we can keep the lead out, but we need ramping. So 0.2 inches, it'll start ramping above 20 thou, check mark, and you see. Just like that. So now we name this side 3/16 end mill, and then you're going to want to run through simulations, the simulation for each of these, just to ensure that everything works properly. Simulate. Okay, so you can see here. Making the center drills first, and then coming through drilling all the way through, as you can see. Alright, slow it down a little. You see it drills all the way through for some of these, but then some of these it doesn't need to go all the way through. Then we're starting to cut out the contours, just like that. And we'll check out side 2. So this side, remember, it's only drilling. So center drill first to mark the holes. And by the way, on the simulation thing, when you see the bottom here, this is like the first operation, the second operation, the third operation. Those ones, they holes that go all the way through, and then these ones don't go all the way through both sides of the tube. That's good, and then check the final side. This side. So this side is only the contours. Trying to verify it's all good. Okay. And so final step, you're going to want to just post these. So this, right click, post process. Once again, the settings, Mach 3 mill, output folder, you're going to output that to the USB that you're going to use to transfer the files to the CNC computer, and make sure the names match up on here. And remember, for these, since it's the same tool and there's no need for any changes in between, you just highlight both and post-process them at the same time. And that will be all for part 3 using the tubing jig, and short video on us. So this one was, so this part right here, it was part of our V1 intake from 2018. So this one was actually sort of it was a fairly interesting program, since we had to cut out about 80% of the tube we had to cut out, and on this side we had to cut out like a big contour. So the finished part, it looked like this. So we had to cut out this giant area here. And it gets, it can get tricky, but there's some workarounds and different different mechanics in a sense you can use with the different features here, which I will also be going over in another video, probably part 4. Well, that's all. Thank you for watching.